guys, this time around I will be creating a 3 episode series that will consist of a code that will be running in our console. For this will be our first episode in which I will be creating an console based application that will delete all the nodes from a doubly linked list that are smaller than a given value. Okay, this means that I will create a doubly linked list which will delete all its nodes which will if they are smaller than the value which the user enters. Okay, so for this I will be creating a linked list which will be doubly linked list, and it will consist of 3 functions. The first function will be of insert function. This function will insert the nodes in the linked list, and the second function will be the delete smaller function. Okay, and there will also be a third function, and this function will be display function that will be used to display all the nodes inside the linked list. Okay, now let's move towards our program. I created a Java class, and you should create this class. Just going to this file, new project, Java application, next, and write the name of your desired class, and you should select this main. Okay, you should be selecting because we will be needing a main class. I am not doing that because I have already created this class around. Now what I will be doing is that I'm going to call the package here, package code 0, and my class will be of, first of all we will be creating a linked list class. Okay, then so we should say class linked list with capital LL, and okay, there is an error. Okay, there is an package. Okay, there you go. So what our linked list consists is that it consists of a head node. Okay, so we will be creating a head node. The reference type of this head should be node, and we will also be creating this node class above here, class, and there you go, public, class node. Okay, now we what should our node class consist of? Our node class consists of two if as we know that it is a double linked list, so it will be consisting of 3 data members. One will be its data, we will say that it is in integer form. Okay, public in value, and then the other two will be the reference to its next node and its previous nodes. Okay, so we will say public node next and public node previous. Okay, there you go. Now our node in our node class the data members have been created. So now what we will be doing is that we will be calling the constructor in this node class by I will be saying that public node, and in here I will say int v. Okay, now what will happen is that whenever this node is created or called, it will be initialized with a value. Okay, this value, and which will become equal to this value. Okay, this value will be stored in this data member, value data member. Okay, so we will say value is equal to v. There you go. By just refreshing, the array is gone. Okay, there we go. And now once our this node class is created, now we will go back to our this list class. Okay, I can also add here doubly because this will be our doubly linked list. Okay, once it is done, now what we will be doing is that we will create our first function, which will be insert function. Okay, so it will not be returning any value, it will be void. So we say curly void insert node. There you go. Okay, whenever this function will be called, it will be given a value that will be this value will be given to this node, and that will be so due to this. Okay, what just happened? Okay, my running is solved. Okay, this value will be written here, and once it is written here, it will be stored in this value of this node. Okay, so whenever this insert function will be called, insert node, a new node will be created. So I will say node is equal to new node. There you go, and the value will be returned here. So this value you can see went here, and where it is passed in this argument. So in this parameter, this argument is passed in this parameter, and when this is passed in this parameter, then it is stored in this value of the node. Okay, there you go. Now what we will be doing is we will be looking in our cases. So whenever the node is inserted, we will say that the node is inserted at the first value. Okay, so when the node is inserted, we can also call this as insert first node. Okay, whenever the node will be inserted, it will be inserted in the first value. So there can be two cases for us. One case could be that if first is equal to null, there could be a case, sorry, if head is equal to null, we had used this head. Okay, if head is equal to null, then that means our linked list is empty. So what will happen is that this head will be certainly pointing towards this node which we just created. Okay, not my node. So this head will be pointing towards this node if there is no value in our linked list. If there is some value in our linked list, then what will happen is that the head will be pointing towards the new node. But before that, what we will be doing is that we will be connecting the nodes. So this head will be having the value which is had before the new node was inserted. So what we will be doing is that we will be connecting the previous value which is residing in this head node with the new node which we have just created. This new node and this head node will be connected. For that, what we will be doing is that we will say head dot previous, there you go, is equal to node. Okay, so head dot previous will be pointing towards this node, and the node, okay, I have to do these brackets. So this node dot next will be pointing towards the value in this head. Okay, once the connection is made, now what we can do is that we can say head is equal to node. Okay, what we did is that we have to make this new node, it is the new node, as a head. So before making this head, before this head points towards this node, what we had to do is that we had to link it. If we didn't have done this before pointing this head towards this node, if we had done it before pointing the head to the node, then the error will be there is that the reference to the previous node will be deleted. So to avoid that, what we did is that we used the previous reference which was there in the head. We said head dot previous is equal to node, and the node dot next is equal to head. This previous and this next is there, you can see in the node. Okay, whenever this insert first node will be called, a new node will be created and the new link will be made. Okay, so this after this our insert first node function has been created. Now we will be going towards our delete smaller function. We will say public void delete small. Okay, and there the user will be entering the value. If the value residing in the node is smaller than this value, then this value will be deleted. All the nodes will be deleted which are smaller than this value. Okay, now we will be implementing this function. We will create a node and we will name it as current, and that will be pointing towards the first, okay, in our case it is head of the linked list. Okay, this current will be pointing towards the head of the linked list, the linked list. Okay, there you go. Now there will be three cases in our delete small. One case can be that the node which we have to delete is residing in the first position of our linked list. Means that when this function is called and this value is called, the very first node of the linked list to which the head is pointing has the value which is smaller than this value. Okay, whenever this happens, we will be creating a code that will solve that and delete it. So we will say if current dot value is smaller than value which is there, you can see, or no, and current dot previous, okay, is equal to node, so it is equal to null. We know that in our linked list, in our doubly linked list, there are two pointers. One is the next and one is the previous of the node. If our previous pointer is pointing towards null, that means it is our first node. Okay, let me show you. We will say that this is our head, okay, and it is pointing towards 2. Okay, head is pointing towards 2, but we should know that this 2 is pointing towards, let's say, 3. So this 3 will also be pointing towards this 2. Okay, this 2 will be pointing towards 3, and but this 2 will not be pointing back towards head. Okay, so we can say that 2 is pointing towards, sorry, null. Okay, and if this 3 of our is last, then it will be pointing towards null 2. Okay, so I will be removing it again. There you go, and I will be adding these brackets. Now I will be creating the code for that kind of condition. So what I will be doing is that I will be changing the first and head, and I will say that head is pointing towards current dot next. Okay, so the head will move one place. Let's say the head was pointing towards 2, and this 2 was pointing towards 3, and this 3 was pointing back towards 2. Okay, so if we have to remove this 2, what we will do is that we will just take this head and we will say that it points towards this 3, and this 3 doesn't point back. Okay, so the link towards this 2 will be lost. Okay, you can see that there is no link here. The 2 is there in the memory, but it is not, but there is no link to it, so we will say that it has been deleted. Okay, so I will be removing this back. Once it is done, so what I will do is that head has pointed towards the current dot next, but there still the link towards the previous node is there, because this current is current dot next is also pointing back towards the previous value. So what I will do is that I will just simply write current dot next dot previous is equal to null. Okay, there you go, the link is gone now. The other condition can be if our node is the last value. Okay, if our last node has the smaller value than the value which the unit provided here, so we will be removing the last link of the node. So for that I will say if current dot value is smaller than value and current dot next is equal to null. Okay, if the current dot next is pointing towards null, then that means that the last node is that we are facing the last node. If the last if our last node have data type data next and it is pointing towards null. Okay, once it is done, I will remove this semicolon here. I'll go to next line, and okay, there you go. Once it is done, I will be writing the code here. I will say current dot previous dot next is equal to null. Okay, now I will say current dot previous also equal to null. So what I did is that, let's say this is our linked list. Okay, let me add the comments. Let's say 3 is pointing towards 2 and 2 is pointing back towards 3, and this 2 is pointing towards 1. Okay, but this 3 is pointing back but to null. Okay, we have solved this scenario. We have solved this scenario. Okay, here here we solved this scenario, and now we will be solving this scenario, which says this one will be pointing towards null. Okay, if our last node is the value has the value that is smaller than the value which the user entered, so we will be deleting it. The steps which we will be doing is that we will say that current, okay, if we will say if current dot value is smaller than value, okay, which we will be checking if it is that, and if current dot next is equal to null, you can say this is current, and if it dot next is equal to null, then we will say that this is our last node. If it is our last node, so how do we remove this link? We have to remove this link. Okay, we have to remove this link. Once this link is removed, and this 2 will be pointing towards null, and so this will be lost in the memory and this will be deleted. Okay, for that what we will be doing, let me tell you. We said that this is the current, which is the last node. We said that its previous, sorry, there is also, we will say its previous, which is 2. Okay, you can see current dot previous, it is pointing towards this 2, and then we will say this previous dot next, which is talking about this link here. Okay, previous dot next, this link, we will mark it as null. Okay, let me show you. We say that it is null. Once it is null, but the issue is that this one is pointing towards 2. We had removed this pointer, okay, but this pointer is still there. We also have to remove that. So what we did is that we said current dot previous, this current and this previous, okay, is equal to null. Once we said that this node is pointing towards null, okay, if it is pointing towards null, then this will be lost, okay, in the memory, and we will get this linked list, and this head will be pointing towards 3. Okay, there you go. Our 2 cases are solved, and the third case is that if the value resides in the middle of the linked list, so we say else if, okay, I can also go here and write else if. Okay, I'm just filling it up. If it's else if current dot value is smaller than value, okay, and what will happen is that we will be removing our in between link. Okay, now let me show you how this happens. If you writing current dot previous dot next is equal to current dot next, and current dot previous dot next is equal to current dot next. Okay, now let me tell you what I just did. Let's say there is our head and it is pointing towards this 3, and this 3 is pointing back towards 2, and this 2 is also pointing towards 3, and this 2 is pointing towards 1, and this one is pointing back towards this 2. Okay, so what we have to do is that we have to remove this node here. We have to remove this 2. So what will happen is that this 3 will directly point towards this one. For that, what we did is that we said this current, now let me first clear you that first we solve this value, which will check if the value is the first node, and the second will check if the value is the third node, if last node, sorry. If it is not the first, it is not a last, then that means the node will be residing in the center. Okay, so this will be the code for our center, and so in the center we will also add a check which will say current dot value is smaller than value, which our question was we have to delete all the values that are smaller than the value which the user enters. Okay, and let me add the comments here. So let's say we have to delete this 2 here. Okay, so for removing this 2, once we are here in this code, and that means that we are pointing towards the center node. Okay, this there is the center node. Okay, now what we will be doing is that we will say current dot previous, which will be this. Okay, and once we are here, then it will also say dot next. Then from this 3 we now we are talking about this link here. Okay, we are talking about this link now, which is pointing towards 2. Let me zoom in for you guys. There you go. You can see that I'm talking about a link which is pointing towards 2. So I will say that no, this link will not be pointing towards 2. Rather, this will be pointing towards the value 1. How will I do that? We all know that the current is pointing towards 2. So I will say current dot next, which means that I'm talking about this link now. Okay, which is 1 here. So I will say current dot previous is 2 dot previous, which is 3 dot next. So which is this node. Okay, so I will say this node will be pointing towards this one, which is current dot next. Okay, there you go. Once it is done, our this link is gone and this will be pointing towards 1. Okay, but there will be an issue that let me show you. There will be an issue that this 3 is pointing towards 1, but this 1 should be pointing back towards this 3. So what we will say is that we will again go to this current, which current is in our case is 2. It's a current dot previous. It will go back towards sorry, I've done some mistake. Let equip it and next, and there will be previous, and around here it will be previous. Okay, so guys, now what we will be saying is that this current dot next, which is 1, and is previous, which is this. So we'll say this will be pointing towards this 3. Okay, current dot next dot previous means that this current dot previous is this 1. Okay, this current dot next is this 1, and we say that next dot previous. Okay, next dot previous means that we are talking about this link. So we will remove just this 2 here, and we will say point towards this 3. So we'll say current, which is 2 dot previous, is equal to current dot previous. So it will be pointing towards this 3. Okay, so our link 2 will be gone completely from the list. So this implementation is just for 3 nodes. First node, last node, and the center node. But if we had many nodes, we can say that if our link list has 1 which is pointing towards 2, and this 2 is pointing towards 3, and this 3 is pointing towards this 4, and this 4 is pointing towards 5. Okay, and this 5 is pointing towards 6. Now you can see that, let me add the comments here. Now you can see that there are 5 just remove this. Okay, 5 values. Okay, now there are more than 3. So in our first, if our first value is smaller than the value which the user adds, so if we are talking about the first node, we can solve it by this program. If we are talking about this last node which is here, we can also solve it. But what about this center node? If we are talking about the center node, we have 3 center nodes. So how will our program know about which node are we talking about? So for that purpose, what we will be doing is that firstly, let me remove this comment. We will be adding a while loop here. While, okay, while I say current dot, not that, I will say current is not equal to null. Okay, and I will be just this code here. I don't think it. Okay, so I did it, and now I will be getting an iteration. So I will say current is equal to current dot next. Okay, now you can see that if we have 5 nodes, if our second node is not smaller than the value, if our second node is not the first node, I mean that if our second node is not the head node, then this code will not be executing. If our second node is not the last node, then this code will also not be executed. And if our second node, in our second node, the value is not smaller than this value, the node value is not smaller than the value which the user entered, so this code will also not be executed. So what will happen is that we will move towards the next node, which will be third node, and we will recheck these things. Okay, until we delete all the small values. This delete small code has been created. Now we will be creating a display method which will display our values. Okay, so we will say public void display. Just I'm going to do is that create a node reference that will be I will name it as current is equal to head. Okay, now I will just add this while loop and say current is not equal to null. If it is not equal to null, then that means that the current is never equal to null. If it is equal to null, then this loop will be not be executed. Okay, so I will just simply print out my value. Okay, I will print out my value. I will say, okay, let me just remove this. Okay, what I will do is that I will just current dot value will be printed in the screen, and then I will just give it a space here. Okay, and let's run the iteration again. Current is equal to current dot next. Okay, there you go. Now what I will be doing is that I will getting the main function. I will say, but for main function I will go in the different class. I will get a new class here, and public class node class. Just remember that you have to use a name which when you were creating the package you named your class. Let me show you again. When you created this project, and the name which you use here, and you check this, okay, you have to use that name which you when you created your class. So I created the core 0 class. So there you go. Now I will be just using my calling my main function public void main. There you go. Now I will just list ll is equal to new name list. Okay, here is my constructor which showing me an error. This error is here because my name is doubly list, okay, not list. So I will just write doubly here and doubly there. There you go. Why? Now I will just call my insert first node. Let me say it is 5 dot insert first node 4 dot insert 3 dot insert first node as 2 dot insert first node as 1. Okay, now I will be removing all the values which are smaller than let's 4. Okay, so I'm calling that function which will remove all the values that are smaller than 4, and then I will just display my this. Let me just run it. Okay, so it does not have a main method. So just go here, against files. Most of you will be in this or this. Okay, there is the file. Just go towards the core 0. This is my source core 0, and just run file. This is core 0 dot core 0 does not have a main method. Let me check. Yes, I just made static here. Okay, let's run it. Let's see. TikTok. There you go. You can see all the values which were smaller than this 4, which was smaller than the 4 have been deleted. Okay, so our program is completed. Thank you all for watching this video, and